All right. Well, hello, everybody, and welcome. My name is Miranda Cook. I'm a program officer at the Mass Cultural Council. Just a couple of orders of business before we get started. Captioning is available during this presentation. Be sure to click the Show Captions button on the bottom panel if you need them. This session is being recorded and it will be available on the Mass Cultural Council's YouTube channel. Please feel free to use the Q&A feature to ask questions that come up throughout the presentation. And there is also a chat that you're welcome to use, but if you have questions that you want us to get to at the end of the presentation, be sure to drop them into the Q&A. And at the end of the presentation, we will open up the floor and have time to answer questions. So with that, welcome. This presentation is for cultural organizations to learn about decarbonizing their facilities. Our presenters and guests with us today include John Beaumont, who's the Director of Engineering at New Ecology, Nathan Jadot, Building Energy Reporting Program Coordinator at the Massachusetts Department of Energy Resources, or Mass DOER, Martha Grover, Policy Advisor for Building Decarbonization at the Mass Executive Office of Energy and Environmental Affairs. And of course, Jay Paget, Program Director of the Cultural Facilities Fund at the Mass Cultural Council. This presentation is to make people aware of the resources for decarbonization available in an effort to align with the state's climate action goals by 2050. And with that, I will pass it to John, who will kick us off.
Hi, everybody. Let me get my slides up here. Can everybody see that?
Yes.
Excellent. Hi, I'm John Beaumont. I'm the Director of Engineering at New Ecology. We are a mission-driven nonprofit seeking to make the built environment more efficient, healthy, durable, and resilient. And we do that in our decarbonization team through research, testing, and implementation of new approaches to sustainability. Sorry, the coffee's not kicking in yet. Resiliency, healthy environments, and energy efficiency. So basically, we go in and we monitor, test, and diagnose things within buildings and look at how to best make plans to efficiently improve their efficiency, improve their comfort, resiliency, and set them on a path towards long-term decarbonization. So a couple terms that are going to be important for this. One is net zero, which is removing greenhouse gases from the atmosphere in an amount equal to releasing it, or in the case of buildings, it's often termed net zero site energy, which means you are either generating as much energy on site as you're using, or you're purchasing renewable energy credits to offset all of your on-site emissions. Decarbonization is the result of actions to reduce or eliminate fossil fuel use by buildings, either directly on site or...
Hey, John.
Yes.
I'm so sorry to interrupt. It seems like some of us are having some issues seeing your slides. We're just seeing a black screen. Would you mind unsharing and then
Absolutely
starting again? I thought maybe it was just me. It looks like some people in the chat are also having trouble.
Is that showing up better now?
I see it.
Okay.
It looks like others in the chat can see it as well. Okay.
Excellent.
I think we're all set. Thank you so much.
Sure thing. So decarbonization is the result of actions to reduce or eliminate fossil fuel use by either your building or other buildings, and it applies to both on-site emissions, so a boiler burning fuel on-site, as well as looking at off-site emissions, what the electrical grid produces in emissions to generate the electricity used on site. And a deep energy retrofit is a systematic forethought leading to investments and decisions over time to reduce the energy use and emissions of building. And emissions are typically measured in carbon dioxide equivalent. So other gases have a different amount of greenhouse gas coefficient in terms of the amount of solar heat that they trap in the atmosphere. So CO2 basically corrects for the differences in emissions and compares them all to CO2 as that baseline. The context for decarbonization here in the Northeast is driven a lot by Massachusetts' goal for net zero emissions by 2050, and surrounding states all have slightly differing goals. Another driver of that are fuel costs. Gas is predicted to rise more than electricity over time. As more people electrify their buildings and there are less customers on the gas pipelines, the cost for each customer will end up increasing pretty dramatically at a certain point. And exactly when that inflection point happens is hard to know. And another benefit of electrified heating and cooling technologies is that they can have efficiencies of greater than 100%, basically by using electricity to move thermal energy versus combustion, which you're basically using a part of the fuel that you burn as heat, and the rest is in the exhaust from that combustion. So you're limited to efficiencies of less than 100%. There are also, local drivers. So building ordinances such as BERDO, the Building Emissions Reduction and Disclosure Ordinance in Boston, that has a series of declining carbon thresholds per square foot that will reduce in increments every 5 years between now and 2050. And also, if you're not meeting those carbon goals, there is a compliance payment of $234 per metric ton of greenhouse gas emissions. So really, it behooves people within Boston to try and plan to keep their buildings below that threshold. Other cities and towns also have performance standards that have slightly different requirements. So Budo in Cambridge requires annual reporting to show emissions reduction in comparison to past performance. Newton is similar to BERDO, but it has more flexibility to reduce compliance targets, in part because it doesn't factor in the emissions from grid electrical use, because that's sort of out of the hands of building owners. So it's more about decarbonizing just site emissions. And then there are other towns like Chelsea and Lexington that currently have benchmarking only requirements. And there are similar requirements in different areas and different towns across the country, and other building performance standards in those places as well, and many others. So part of a decarbonization plan is something called a zero over time plan. And that is, how can we plan to improvements to incrementally reduce emissions over time with the goal of approaching and hitting net zero. So in this chart, you see that red line is a sample project's current emissions if they were to do no efficiency work in the building. And you'll notice it still does decline slightly over time, and that's driven by as more renewable fuels are added to the electrical grid, the emissions from that reduce, whereas emissions from the gas fuel use would stay constant. That's driven by chemistry, not by other things. And so the green line would be the BERDO emission standards, and this is for a multi-family housing project, not a cultural project. But you see, as they introduce capital projects and certain other measures to improve the efficiency of the building and to electrify it over time. You see the building's emissions are sort of dropping in line with the requirements. So decarbonization approaches, first thing we want to think about in any building is how can we reduce the loads? And that means the loads the heating and cooling system needs to condition the building. So how do you keep it comfortable when it's hot or when it's cold, and what is the energy use from that? So things like insulation can reduce loads, improved lighting can reduce electrical loads and heating loads in the summer. And then we want to look at improving the efficiency of systems and electrifying those systems. And sort of lastly is renewable and on-site generation where possible. But we don't really want to start there because there's, no sense making a building's performance look better when it's really not a high-performing building. Really, you want to focus on reducing those loads so that your renewable energy can be as effective as possible at reducing overall emissions. And sort of the costs to reduce load for envelope-intensive buildings and the amount of savings you get is relatively high for a relatively low cost over time compared to a mechanical system intensive building. And that would be something like a lab or a hospital versus something that does not have very high internal loads, such as, homes or performing arts centers or churches, things where the internal loads don't really require a mechanical system to do more than temper based on outside conditions. And as we look at envelopes, thermal imaging is kind of a good way to see. So you can see that blue building in the middle has been insulated from the inside. And there's still some leakage around window frames and other things, but compared to neighboring buildings where you see the bright reds and yellows, that is energy just coming out through single pane windows and uninsulated brick walls. They're really not very thermally resistant. And I can also guarantee that whoever's sitting near the windows inside that well-insulated building are far more comfortable even on a cold day. So as we look at, envelopes and heat loss, what we want to do is try and reduce where in the winter where the heat is escaping the building, where it's leaving. And ideally, by improving that insulation, we can reduce the loads that the mechanical systems need to condition so that we get smaller, less costly, more efficient mechanical systems that don't have to run as often either. One method of that for roofs would be something like structurally insulated panels, where you've got particle board or plywood on either face and insulation in the middle. And those panels basically don't need much structural support. They are structurally sound as well as insulated. They're a little more complicated if you're trying it in a wall because there's nowhere for power for electrical lines to run. But in walls, things like dense packed cellulose or rigid foam, in sub-slab, sub-grade areas where you're concerned about moisture, can all be effective options. So here is an example of what a structurally insulated panel on a roof looks like. And it certainly would require some different trim details because you have that, it looks like 8 to 10 inches of foam all consistently over that roof. And then you can also see holes down below where they were likely blowing in cellulose. And so then this is sort of the finalized building once trim details are finished out on that and trying to disguise that added thickness while still maintaining, the look of the facade. And things like this are another example of ways to retrofit certain walls. And, this brick building, obviously, there was certain facades that you could not insulate and sort of extend on, either for historical requirements or other reasons. But then on the non-road facing areas, they were able to cover that up and reduce things. Heat pumps are going to be a very important way for electrifying buildings, heating and cooling systems. So a way to think of it is an air conditioner is a heat pump, but it only operates in one direction. So if you've got a window air conditioner, it's blowing cold air into the building, but then there's hot air blowing outside. So it's similar to sort of that coil in the back of a refrigerator where you feel the heat coming off of it. So a heat pump basically takes that cooling system and can reverse it to provide either heating or cooling in a building. And it's only using the electricity to basically move the energy either from one source to another. So ground source heat pumps use water from underground to move energy, and sometimes that's called geothermal, but we don't really have much volcanic activity here, so we'd have to go pretty deep to actually get heat. So really, it's just about a stable temperature source to run heat pumps. And air source heat pumps are also a good way, but they're slightly less efficient because on a negative 10-degree day, you're needing to pull heat out of that negative 10-degree air. And on a 100-degree day, you're you're rejecting heat to 100-degree air to pull cooling from it, basically. And there are lots of different options for heat pumps. This example is a multi-zone mini split. So you've got one outdoor condenser and multiple indoor units. One other complication with that is refrigerants have their own greenhouse gas and global warming potential. So ideally, unitary systems are better where all of the refrigerant has been done at the factory and there's no field installed refrigerant piping to potentially leak. But there are also requirements over time where manufacturers are required to phase out certain refrigerants in favor of others with less harmful global warming potential. Another option, if you've got a building that has existing radiators and hot water piping for heating, there are heat pumps that can take energy from the air and transfer it to water and retain that distribution system within the building. And then there are air to water to air units where you're basically using water as a medium, but transferring it within the building. Ground source, as I said, is really just a way to take a heat pump and have a more stable energy source that you're moving energy to and from, so that the heat pump is always able to operate at its most efficient state. There are certain communities in Massachusetts, Lexington is one, where they're trying out a district geothermal system where basically multiple buildings are looped together. So the idea is to replace natural gas piping with water piping shared between the buildings and with a geothermal loop there. So the nice thing is if you have a factory that's always needs cooling, it will always be rejecting heat to that loop. And then homes and businesses that need heating could pull that off of it. Or if there was a community pool that always needs heating for the water, it's always rejecting cooling to that loop. And so now in the summertime, it sort of balances that temperature and can improve the efficiency of a larger neighborhood system. It's a sort of a new way for utilities to look at moving energy between buildings. And when we get to renewables, there are things like solar or wind, although often wind is harder on sort of a single building scale. There are even heat pumps that use refrigerant as that use carbon dioxide as their refrigerant. So the advantage of those is that they are very, very effective in heating systems. They're not as good at cooling yet with the technology. We're still trying to catch up to some European systems on that. on that side here in the United States. And another important element is, as we make building envelopes tighter and insulate them more, we need to make sure that we're ventilating them properly to reduce any pollutants in the building. And a way to do that efficiently is the use of an energy recovery ventilator that, on a cold day in the winter, is able to capture some of the energy from air that you're exhausting when you're bringing fresh air into the building, so that you're not paying to heat up 10-degree air on a cold winter day all the way. You might only have to heat it 30% of the way up to your indoor temperature by recapturing some of that energy. From a resilience perspective, as we've all seen storms getting larger and larger over time as climate is changing, and there's sort of more energy and water potentially going into some of these storms, leading to greater flood risks. And so, along with looking at the efficiency of a building from an energy standpoint, you can also look at it from a resiliency standpoint. So this is either flood mitigation things like this panel, or trying to locate mechanical and electrical equipment above anticipated floodplains, so that in the event of something like that happening, the building's equipment is in a safer location. A project that we had done an assessment on in the past is the Fine Arts Work Center in Provincetown, Massachusetts, out at the end of Cape Cod. And this is kind of an interesting one. It had housing for artists, and we did a decarbonization assessment for them. And when they started looking into the design, they actually figured out that the town is switching to centralized wastewater management, and they no longer need their septic system and leach field. So they actually had real estate that they could expand on. And they've now sort of taken that initial decarbonization assessment, and through looking at feasibility, decided that it makes more sense for them to actually tear the building down and start again, taking advantage of that expanded footprint to offer five more units for artists. With resiliency assessment, there are things like tools like the Resilient Mass site that shows the risk of coastal flooding, as well as the risk of urban flooding from rain events. There are wind speed assessments in there as well. So looking at co-benefits besides just your reduced energy costs, there would be things like improved passive survivability. So the building's temperature will remain more stable if there is a storm or an outage. So if a snowstorm were to knock out power, the building's temperature, if it's well insulated, would stay stable longer and be less likely to have pipe bursting or other issues. So those secondary benefits are also something to consider when looking at these things. In terms of resources, there are mass save incentives. There's the Massachusetts Clean Energy Center beta pilot as carrots, and there's, of course, Mass Cultural Council that we're on this call for right now. Plenty of different mass save incentives that are different for different types of projects. With that, I will pass things off to our next presenters. Thank you so much.
Sorry about that. Thanks so much, John. With that, we can pass it to Nathan.
All right, get my slides up here. All right, good morning. Thank you all so much for coming and allowing me to join you here on a beautiful autumn day in New England. My name is Nathan Jodl, and I am the Building Energy Reporting Program Coordinator here at the Massachusetts Department of Energy Resources. Today, I'll be giving you an overview of the Commonwealth's new Large Building Energy Reporting Regulation, which we call LBER. We have a wealth of resources online that really go into the nitty-gritty of this program and provide detailed step-by-step instructions for building owners. But this morning, I'm more going to focus on a high-level overview of the program. And then I'll be happy to answer any questions you have about the finer details at the end of the webinar. So to start, I'll give a broad overview of LBER. Then I'll talk about how to find out which buildings are covered by the regulation, what the key action items are for the owners of covered buildings. I'll be talking about a few different websites and online forums as I go, and I link to those all at the end, so don't worry about taking notes. We can share these slides after the presentation, and that should give you all the resources you need. So for those who don't know, the Department of Energy Resources, or DOER, is the Massachusetts State Energy Office. DOER's mission is to create a clean, affordable, resilient, and equitable energy future for all in the Commonwealth. DOER supports the Commonwealth's clean energy goals as part of a comprehensive administration-wide response to the threat of climate change. DOER focuses on transitioning our energy supply to lower emissions and costs, reducing and shaping energy demand, and improving our energy system infrastructure. DOER implements this policy through planning, regulation, funding, and stakeholder engagement. And DOER provides tools to individuals, organizations, and communities to support their clean energy goals. We are fully committed to transparency and education, supporting access to energy information and knowledge. So next, we'll start with the overview by discussing where LBER comes from. All right, so Large Building Energy Reporting, or LBER, is the name of a policy signed into Massachusetts law in the 2022 Act driving clean energy and offshore wind. It requires DOER to publicly report the energy usage for all buildings with a gross floor area of 20,000 square feet or larger on an annual basis, starting this year for energy used during the calendar year 2024. It requires electric, gas, and steam utilities to report the energy use data they have for covered buildings to DOER, and requires covered building owners to report data about any additional energy used in their building from delivered fuels. It also requires DOER to publicly report energy usage by building, meaning that public reports of individual tenant data will be aggregated up to the building level. The primary purpose of building energy reporting or benchmarking policies is to create data transparency in the market, allowing stakeholders to understand more about how buildings use energy. Also, as cities and towns in Massachusetts continue to implement building energy policies, the statewide reporting standard allows them to focus on implementing the policy rather than worrying about how to collect the data, which is really the labor-intensive part of the process. So examples of such policies include Berto in Boston and Beto in Cambridge, which Sean discussed earlier. The standard also helps provide certainty in the market for owners across jurisdictions, ensuring that they are able to report in the same manner for their portfolio across the state. In 2024, DOER solicited public feedback on a draft regulation for large building energy reporting and made edits based on the feedback received. The regulation was changed based on that feedback and finalized on February 28th of this year. The regulation provides more detail about the legal obligations of the various parties, including deadlines for compliance, how reporting works, and how we'll treat buildings subject to Berto and Beto. It also establishes a set of additional guidelines DOER will publish after a public input period on proposed drafts. DOER established this guideline process to ensure that you as stakeholders have a clear path to weigh in on the implementation of the details and shape future process changes. So if your building is on the covered buildings list, either you or your utility company will need to report your energy usage annually by June 30th. Your gas, electricity, or steam utility can provide the usage they have for the building directly to DOER. You will have an opportunity to review the information provided by your utilities at some point after that deadline, although this timeline is likely to change in future years. This year we got energy data from utilities at the end of June, and starting next year, we do expect to get that information a little bit sooner, which will give building owners more time to review. So if you only have gas, electricity, or steam from a utility company, you really won't have to take any further action to report data. If you have other sources of energy usage like oil, propane, wood, on-site solar, for example, you then have until June 30th of each year to collect and report usage information from those sources. And then DOER will publish that data received annually by October 31st. And so, just recently we published our first data set for this first year of the program. So the covered buildings list is the list of buildings used by DOER to determine which buildings are covered by the regulation. The list was developed by our vendor Clearly Energy with the goal of cataloging all buildings with a gross floor area of 20,000 square feet or larger throughout the Commonwealth. This list will include the building's address, the name of the owner of record, and an identification number called a UBID, as well as several other fields. There will be several ways for you to check if your buildings are on the covered buildings list. You can look through the full list itself, but an easier way may be to use the interactive map that we published. On the map, you can either zoom to your location or search for a specific address to find your buildings. And so if it's on the map, that means it's on the covered buildings list. Written notices were also sent out to building owners informing them of any buildings they own that appear on the covered buildings list. These letters sent to the mail were typically sent to the owner address listed in the assessor's database. And then once you start engaging with us and provide a point of contact, we switch over to email communications instead for future notices. The covered buildings list includes large buildings all throughout the Commonwealth, but if your buildings are in Boston or Cambridge, the reporting process under this regulation may be streamlined thanks to those local ordinances that are already in place in these cities. If you have a large building in Boston or Cambridge, you may already be reporting under either BERDO or BUDO, and we really want to make reporting as simple as possible for building owners. So if you have a building reporting under one of those ordinances, there will be no additional reporting under the state's program. Boston and Cambridge will share their energy usage data for their buildings covered under the ordinances with DOER. And so as long as the building's BERDO and BUDO submissions are complete, those submissions will be used to check the box that your building is in compliance with the state's program. DOER's large building energy reporting program does have a slightly different definition for a covered building compared with programs from Boston and Cambridge. So there will be some cases where a building in either city may need to report under the state's program, but not under BERDO or BUDO. And just for example, the state's program covers buildings with a gross floor area of 20,000 square feet, but the cutoff for BUDO and Cambridge is 25,000 square feet. So there will be some gap there. So if you have a building on the covered buildings list, the first thing a building owner should do is designate someone to claim the buildings on our website and be the point of contact for the program. The slides have a link to the online form that we use for this process. And doing this ensures that we have the proper contact information for each building so we can update you about the program all throughout the year. And then as you review the covered buildings list, you might see something that needs to be corrected. Maybe a building is missing, or maybe you see a building on the list that's under 20,000 square feet. Maybe it's over 20,000 square feet, but the square footage listed is incorrect. Other times the building's address differs from the address that we have on file, which is usually taken from the parcel where the building is located. And there are a few cases where buildings might be over 20,000 square feet, but should be exempted from the regulation. Don't know how common these would be for this audience, but for example, if a building was vacant for all of 2024, we would exempt that building from this round of reporting. The knowledge base on our website offers a wealth of information on the program and how to comply. We have a lot of information there now, and it will continue to be built out as we gain more experience with this program. The website also has a help desk system. So in addition to submitting a claim my building form or making corrections to the covered buildings list, you can also just submit a general inquiry with literally any question you might have. Or you can email us at the email address listed on the slides there too. Back in May, we hosted a 90-minute webinar focused entirely on the details of the reporting process. So you might want to review that if you want to really dive into the particulars. And the slide here has a link to a recording of that webinar. For now, I'll just briefly touch on how we use Energy Star Portfolio Manager in this program. For anyone not familiar, Portfolio Manager is a free online platform for tracking building energy use. It's essentially an industry standard and used across the country for other benchmarking programs. Many building owners already manage their own Portfolio Manager account, and if they wish to share their building data with us, and if they wish, they can share their building data with us to comply with this program. This is not required, though. We expect most building owners will prefer to have DOER manage this process. We will be able to create a record in our own Portfolio Manager account for you, and then have the utilities push the energy use data to our account. And then we can always share that back with any of you at any point. The only case where we would require building owners to use their own Portfolio Manager account is if they have delivered fuels or on-site generation, like from solar panels, that they need to report. All right, so we're coming to the end here. So since we are at the end of our first reporting year for this program, it's possible some of you have already engaged with this program and done all of this already. And if you're one of those folks, thank you very much. For those coming to this fresh today, the first thing you should do is have someone claim your building on our website. And if needed, submit a request for a correction or an exemption for your buildings. And if anything at all is unclear as you're doing these things, please reach out and I'll be happy to walk you through it. And John provided some great resources. Here's a few more here with links to some of the forms and resources specific to LBER, and then some links to some of those carrots that he mentioned as well. So thank you. I'll turn it back over to our gracious hosts, and they can take it from there to bring on the next speaker or move on to some Q&A towards the end. Thank you.
Thank you so much, Nathan. Next up, we have Martha Grover.
Hi there. Thanks for including me in this webinar today. It's a really important conversation about everyone's role in preparing our buildings for the future we want to see. I'm Martha Grover, Policy Advisor for Building Decarbonization at the Executive Office of Energy and Environmental Affairs, or EEA, which is the umbrella agency that includes the Department of Energy Resources, where Nathan works, the Department of Public Utilities, Environmental Protection, and several others. So I want to just spend a few minutes to provide additional context about why decarbonizing your cultural facility is important. Within EEA, there's a climate mitigation team I'm on that's working on policies and programs to reach our ambitious greenhouse gas reduction goals in three main categories: buildings, electricity, and transportation. Our work is guided by the 2021 climate law that requires the Commonwealth to reduce emissions by 50% by 2030, 70% by 2040, and at least net zero in 2050 below 1990 levels. And in addition, Massachusetts has what we call emission sublimits, or targets, that are set in 5-year increments in reports that we call the Clean Energy Climate Plans, or CECPs. The 2025 and 2030 CECPs were published in 2022, and we're already working on the 2035 Clean Energy and Climate Plan, which the legislature says we need to have done by January 1st of 2028. So the work is ongoing and we're always thinking ahead to the future. So my area of focus is buildings and coordinating efforts and initiatives across EEA agencies that are working now to achieve our 2030 sublimits. And the LBER is one example of many policies and programs the state has adopted to advance progress in the building sector in line with the climate law. As John said, for buildings, the overall strategy is reducing energy use through cost-effective energy efficiency measures first, and then replacing fossil fuel equipment and appliances with electric options, most often heat pumps for space and water heating. And then the idea is that as we transition buildings and transportation away from consuming fossil fuels to electrification, the energy supply powering those buildings and transportation is getting greener over time. Challenge, of course, is doing this affordably and equitably, which is a high priority for the Healy administration. Again, also reiterating what John already said, the most common and pragmatic approach is what we call zero over time, rather than electrifying everything all at once, which requires a roadmap and planning with the help of expert consultants like New Ecology, leveraging every available mass save incentive out there, and upfront project funding and grants like the Cultural Facilities Fund. So one example of this is something that I do in my free time, which is serving as the treasurer of a small nonprofit community arts center. It's housed in a 4,000 square foot 1880 Victorian house that used to be the parsonage for the church next door. When we moved in, like probably a lot of you, we had to address many years of deferred maintenance and upgrades to turn it into a public space for classes and artists. We applied for and received a CFF grant, which we used for a number of those projects. Starting with an assessment, we then installed insulation where we didn't have it to cut down on our energy use, and then removed the old oil furnace and radiators and replaced them with air source heat pumps or mini splits, which are strategically installed throughout the house to provide efficient heating and cooling in every room. Switching from oil to electric heat pumps saved us money right away, and now the building is completely fossil fuel free and also more comfortable for all of our visitors and staff. In closing, I just want to first acknowledge that reducing energy use and adopting clean heating solutions in existing buildings is not simple. It's a complicated process. It requires a lot of decisions along the way. Help is available to assist your organization on this journey, and I think this webinar is a great starting point. So I thank you, Miranda and Jay, for offering this. Happy to answer questions, but I'll turn it over to Jay to talk about the Cultural Facilities Fund next. Thanks.
Thanks, Martha, and thanks, Nathan and John, for kind of setting up the conversation. Yeah, we realize everyone on the call that's presented so far is in this work knee deep every day. And we realize that most of the folks that manage and run cultural facilities, your expertise is probably more aligned with arts and cultural programming and running organizations. So this is where I think we can connect the dots between the Cultural Facilities Fund and getting the expertise that's needed for you to decarbonize your facility based on the number of approaches that John has laid out. New Ecology is one of the consultants we have seen the cultural facilities sector employ to do a deep dive with the green energy retrofit and or new building. So Cultural Facilities Fund has a couple different kind of grants. We have planning grants, and we also have implementation grants. We're certainly open for business, so to speak, with any planning you wish to do insofar as decarbonization and energy efficiency. You can use the Cultural Facilities Fund to pair that work with other capital needs that you have on your list. So we're very much accustomed to seeing a scope of work that covers a few different areas. So you can like the 0 over time program, you can take this iteratively. Your application doesn't have to be 100% reduction in fossil fuels, but if you want to go at it sort of strategically while you're taking care of other things in the building, you can certainly do that. One way we've incentivized this is that in most cases, you have to either pick a planning or a capital grant, with the exception of you can actually request a capital grant and a planning grant, provided that the planning grant is to electrify or decarbonize or make your building more energy efficient. We want to incentivize this work. We realize that the targets the state has set are bold but necessary, right? So we're all trying to do our part to clean up some of the issues that are happening with climate, and we want to incentivize that in any way we can. So Miranda and I have office hours every Tuesday and Thursday at 10 a.m. And you can certainly come in. We'll drop the link to those at any time to ask questions about how to approach the application and how to incorporate any electrification or energy efficiency measures in your project. With that, Miranda, I don't know if I'm missing any of the big picture, but we can certainly open this up for questions. And
Yeah.
I think the Q&A is the method to ask the questions, Miranda. Is that correct?
Yes. So please feel free to drop your questions into the Q&A. We don't have very many, but there were a few that were asked and answered during the presentation. So just for everybody, we can go ahead and just say those out loud in case anybody missed them. There was a question about if a building is vacant, there's no reporting requirements. And Nathan responded and said that's correct. If a building is vacant for a full calendar year, you can request an annual exemption. There was another question for Nathan from Suzanne. She asked, are there any plans to make smaller buildings require an energy assessment that is being required for larger buildings? And Nathan, I don't know if you want to talk a little bit about that or if you want me to read your response.
Yeah, I can take it. You know, the large building energy reporting program doesn't require an energy assessment. We're just gathering the energy consumption data. So it just requires reporting, you know, the usage. You know, that could be, you know, what's on the bills or what the utilities provide to us if you would like to have them do that on your behalf. And then there's no plan to lower the threshold from 20,000 square feet at this time.
Thanks, Nathan.
Mm-hmm.
We have a question in the Q&A from someone from a small arts nonprofit with part-time staff. They're experiencing a lot of confusion around how to access mass save incentives. For example, if they want heat pumps, is it best to approach the gas or electric utility company? Also, HVAC installers they have approached seem to advise retaining fossil fuel heating as a backup. So does anyone have any suggestions on where to start and advice on navigating this process? It sounds like this is a question around mass save specifically. And you know, maybe no one on the call here today is the right direct point of contact, but we did do another webinar a couple of years back specifically on mass save, and that's a resource that's available on the Mass Cultural Council's website, and I will drop that into the chat.
I'm happy to answer that. Looks like John may have had a response as well.
Go ahead, Martha.
Well, I would just say that the first question is the type of account that your facility is. Interestingly, when we took over our the parsonage, it was still on a residential account. So you have to look at your rate code. But if I'm assuming that your nonprofit, your small nonprofit is likely a small commercial business, a small commercial code in a Eversource or National Grid territory or Unitil. So, you just go straight to Mass Save and start with the small business assessment process. I can put in the chat, and you don't, when you call Mass Save, you get, you're served by, all 10 utilities support and are sponsors of Mass Save. So it's not like you're calling one utility or the other, you're calling Mass Save, and it's funded by, all ratepayers and supported by all utilities. So it's, but I can put in the chat the small business starting point, assuming that you're on a small business commercial code, and go from there with an assessment. And John, did you want to answer the other question about the backup?
Exactly. That's what I was going to touch on. So it really depends on which system they end up selecting for your project. There are cold climate heat pumps that can have adequate outputs down to -13 degrees, and some I think are coming out even lower than that. Sometimes it's a cost question, because as it gets colder, the energy, it decreases in the efficiency of that system. So there can be a point where, for the next few years, at the very least, the gas system might be more cost effective at very low temperatures. But those low temperatures happen a fraction of hours a year. One side benefit can be that, a boiler and a pump can be run off a much smaller generator for backup heat when the power is out, that a heat pump is not able to do in the same way. I hope that helps.
Thank you so much, John and Martha. We have another question. Do you have any advice on insulation to minimize heat loss for a conservatory structure primarily composed of glass panels?
It would need to be looked at to see what the options are. That can certainly be a challenging structure to insulate and improve the thermal efficiency of it, because the metal structure supporting the glass is often quite highly conductive, and architecturally it can be hard to put a more insulated glass in that frame. So it really it would have to be looked at more closely. I can't really answer on a forum like this.
Thanks so much, John. We have a question about circulating the links we're providing in the chat, and yes, we can certainly do that after this webinar. We also have a question about, from Dasha, can we apply for both capital and for planning if the planning is for electrification? And yes, that's exactly right. So that is the one instance where you can seek both a capital grant and a feasibility and technical assistance grant at the same time, as if the feasibility grant is for the purpose of electrification.
Miranda, I have a question, if I could jump in quickly. This has to do with Portfolio Manager from Energy Star. Is that a resource that is available to any arts and cultural nonprofit, regardless of building size?
It is, yeah. I mean, you could even enter your home energy use in there if you wanted to. It wouldn't really I do out of pure curiosity, but
So if an organization wanted to start to quantify their energy profile, this is and is it a steep learning curve with this, or is it relatively?
no, it's
Understandable.
relatively easy, and for small accounts, sometimes there are even links directly to your utility where they can auto-populate that for you.
Great. I just dropped the link to the portfolio manager in case anyone wants to register.
Nathan, I can tell you're talking, but we can't hear you.
How about now?
Yes, hear you.
Portfolio Manager also has just a ton of videos and other step-by-step resources available too. So tons of educational material out there for it.
Thanks, Nathan. We have another sort of technical question. Are there ways to insulate older glass windows that are panes in a wood frame building?
Yes. There are, vacuum insulated glass units that can look like single panes and can be put in an older wooden frame. And there's always storm windows, or whether it's an interior storm or an exterior storm. Those aren't necessarily as visually appealing, but there are definitely different methods for insulating older wood frame windows.
Thanks, John. I don't see any other questions in the chat or the Q&A. So if no one here has any further questions, as we're at the hour, we can probably wrap up here. We will send around links and resources and in an email, and we'll also have the recording of this session available on the Mass Cultural Council's YouTube page, likely within the next week. So with that.
Yeah, thanks for attending, everyone. The Cultural Facilities Fund application is open till December 11th, and we're here to answer any of your questions. And I want to thank John, Nathan, and Martha for educating us a bit more about the environment we're in and what's coming in the next few years. We appreciate their expertise, so please feel free to reach out to us with any questions.
Thanks for having us.
Thank you.
Thanks, everyone.
Thanks all.